Hello all, I am Dr. Prabhas Chanjanmal. In today's class, we'll discuss about two-stack push-down automata. We have already discussed about one-stack PDA. What is the difference between one-stack PDA and two-stack PDA? Say one-stack PDA and two-stack PDA. What is the difference? In case of one-stack PDA, we always generally uses only one stack, or we can say like one memory. For example, language L equals to a to the power n, b to the power n value is greater or equals to 1. Here, how many comparisons will be required? In this case, only one comparison will be required, because suppose n number of edge here, n number of edge follows n number of bits, n number of edge follows n number of bits, means similar number of edge always follows similar number of bits. Only one comparison will require. But in case of two-stack PDA means we'll use always what? Two stacks. We'll always use two stacks. Two stacks means we can say like more than one memory will be required, more than one comparison will be required, we can say. For example, language L equals to a to the power n, b to the power n, c to the power n value is greater or equals to 1. Same number of, in this case, in this example, same number of edge follows same number of bits, and same number of bits follows same number of bits. That means n number of edge follows n number of bits, and n number of bits follows n number of bits. Means here two comparisons will be required. Here how many comparisons required? Two comparisons will be required. Since two comparisons will be required, we must need two stacks. For one more example, so we can say like language L, a to the power n, b to the power n, c to the power n, d to the power n value is greater or equals to 1. Okay. So in this example, how many comparisons will be required? See, same number of edge follows same number of bits, same number of bits follows same number of seeds, and same number of seeds follows same number of D. Same number of D. So in this case, how many comparisons? 3 comparisons. How many? 3 comparisons. In the first case, only one comparison. Only one comparison. In the second case, 2 comparisons will be required. In the third case, 3 comparisons will be required. So when we'll require only one comparison, in this case, we'll apply one stack PDA. We'll apply one stack PDA, because one stack is sufficient for one comparison. But when we'll require more than one comparison, like more than one comparisons, like 2 comparisons, 3 comparisons, in this case, we'll use two stack PDA. We'll use two stack PDA. Two stack PDA means it generally uses two stacks instead of one stack. Instead of one stack, it generally uses two stacks to handle or to construct the push-down automata. This is called as what? Two stack PDA. This is called as what? Two stack PDA, or we can say two PDA. In short, it is called as, sorry, not two PDA, two stack PDA. Two stack PDA. Okay. Now we'll design what? Two stack PDA for the following language. For the following language, what? L equals to a to the power n, b to the power n, c to the power n value is greater or equals to 1. Okay. So now we'll see the transition function. Let's say, just remember one stack PDA. Just see one stack PDA. In case of one stack PDA, or in simply it is also called as push down automata. In simply it is also called as push down automata. So what is the transition function for one stack PDA, or we can say like push down automata in single PDA? Here transition function is what? Q summation union epsilon to tau tau to what? Q tau star. Okay. In the left part here, in case of push down automata, in the left part it is called as what? 1 stack. In the right part it is here 1 stack is there. But in case of 2 stack PDA, see, in case of 2 stack PDA, what happens? In case of 2 stack PDA, here the transition function means the transition function of 1 stack PDA and 2 stack PDA. Both are same but a little bit different. Just say, in case of 1 stack PDA, we just uses 1 stack, or in case of PDA or 1 stack PDA, we just uses 1 stack here. But in case of 2 stack PDA, we'll just use 2 stacks. Means the transition function will look like Q summation epsilon. This is called as the tau 1 cross tau 2 to Q tau 1 star what tau 2 star. That means this is first stack, and this one is second stack. This is called second stack, and this is also first stack, and this is also what? Second stack. Okay. So now we'll use the given transition function to construct the 2 stack push down automata. Okay. Now we'll see. What is the language? The language L equals to a to the power n, b to the power n, c to the power n, n value is greater or equals to 1. First we'll check, can we construct or can we design the given can we design the push down automata for the given language or not? Okay. Since here 2 comparisons will be required, so we cannot design the push down automata for the given language. So we can construct the 2 stack PDA. So what is the meaning? Just see. So here I'm just taking one more example here. Triple A or double A, double B, double C. Double A, double B, double C. So here we'll use how many stacks? 2 stacks. Stack 1 and stack 2. This is stack 0 and stack 1. There are 2 stacks. Initially, stack 0 contains Z0 initial element, and initially stack 1 contains Z1. So here, what are the mechanism? What is the mechanism first? What is the mechanism to to accept the given language? So here first we'll what? Push double A in stack 1. First we'll push double A. Means I'll push A here, then I'll push a second A here. In Z0 means first stack. Then when the push down automata read the first B, the first B will pop the top of the stack, top of the first stack. Then again B will push on the second stack, means stack 1. So the second B will pop top of the element of S0 stack, and again push on S1 stack, means second stack. Then C will pop this B, then the next C will pop the next B, then pop initial element of S0, then pop initial element of S1. Now my both stacks are empty, then the given language is accepted by the 2 stack PDA. This is the actual mechanism. Okay, now we'll construct. Now we'll design the transition function. So we can also construct means a transition diagram or transitions for means for the push down automata. But here we'll construct the transition functions or transitions for the push down automata, just like in case of means what we designed in the previous classes for push down automata. Okay. So first, so now we'll design two stacks here. S1, this is S2. So initially it contains Z1 and Z2. Initially it contains Z1 and Z2. Okay. First one. Okay. First transition. Del, I'll start from the Q0. Del Q0. I'll read what? A. What is the top of the stack? What is the top of the stack? Top of the stack for first, means top of the first stack. Top of the first stack is Z1. So this is Z1. What is the top of the stack means? In the second case, this is Z2. Okay. So Q0, A, Z1, Z2. Z1 means this one is for first stack and this one is for second stack. So equals to what? Del. Then I'll push what? So see, I'll push the given A in S1 stack. Now S2 stack will empty. Now S2 stack will empty. So that means what? This is Q0. Here I will not change any state. Q0. But so A will push on first stack. A will push on first stack. That means I'll write A Z1, A Z1 comma Z2, because I will not perform any operations on the second stack. I will not perform any operations on the second stack. So Z2 will be blank, or Z2 will be empty. Next, the second one. Then I'll read the second A. Then I'll read the second A. Then I'll read the second A means the second A will push here. So del Q0. What will be read? A. What is the top of the stack? Top of the stack in case of first stack, this is A. I'll just write A here. What is the top of the stack in case of second one? Z2. I'll just write Z2. This is del, then Q0. Okay. So here in A will push here. So that means I'll write what? Double A. So in the second stack will be empty. Just simply write this is Z2. This is very simple. Means it's just like one stack PDA, or we can say like PDA, push down automata. And third one, del Q0, read what? B. What is the top of the stack in case of S1 stack? A. What is the top of stack in case of S2? That is Z2. This is del. Okay. So we have already discussed when we'll change from A to B. In this case, what I'll change the state. Why I'll change the state? I have already discussed many examples in the, just see, just watch the previous video. Previous video of push down automata. Okay. When I'll go from A to B, then here I'll change the state. So this is Q1. Okay. So that means here means the B, the first B will pop top element of S1 stack. Pop means, so I'll write here epsilon, means in the first stack it will pop. What will be the in the second case? So B will push here. So B will push on the second stack. That means this is B Z2. This is B Z2. The fourth one, del Q1. Then it will read what? B. What is the top of the stack? A. Here top of the stack B. then del q1, here that will be pop, b will pop, a pop, so then b will push on second stack, that means b, b. Okay, so then next one, del q1 read c. What is the top of the stack? In case of first one means s1 stack, this is z1. What is the, sorry, z1, what is the top of the stack here? B. So del, so when I'll read means I'll go from B to C, I'll change the state, this is q2 C. C will pop this B, C will pop this B, so means here S1 stack is empty, here S1 stack is empty, means I will not perform anything. So this is epsilon, sorry, not epsilon actually. This is just like a Z1, I can say Z1. Then here pop means epsilon. Then next one, sixth one, del q2. I'll read what? C here. Here top of the stack Z1. Here top of the stack B. So del q2. Here S1 means S1 stack, that will be empty, means I'll just write Z1. Then C will pop the top of the stack, that means epsilon. Okay. So now the stack 1 and stack 2 both are empty except what? Initial statement. So now we'll remove what? Z1 or Z2, means we'll pop seventh one, del q2. It will read what? There is nothing, means epsilon. The top of the stack Z1, the top of the stack Z2. Okay, so del q2 state, so just pop means epsilon, here we'll just pop Z2, that means, sorry, this is epsilon. Okay, now pop all elements. So now S1 means first stack is empty, then second stack is empty. So this is the given, means given transitions for the given language. We can similarly design the means transition diagram also. How to design the transition diagram I have already discussed, means many examples in case of means push down automata. It is completely same as means push down automata and two stack PDA. Just watch the push down automata, means first video of push down automata, please. Okay, so in the next class we'll discuss one more example of means two stack PDA. Okay, thanks for watching.